Hey kiddos, this is Module 3, Topic 3, Lesson 2, Expressions that Play Together. In this lesson, you will model and solve equations using a double number line. Now, this is not the first time that you've seen a double number line. Previously in 6th grade, you used double number lines to compare two different variables or two different things that still show the same quantity or the same amount. For an example, if I'm going to the fair and I want to play games and I know 5 tickets is going to cost me $6, well, I can use that ratio to then also determine, well, if I want 20 tickets, I know that's going to cost me $24. These two amounts are equivalent, number of tickets and their price in dollars. The only difference in 7th grade is now we're adding in variables to represent an equation. And of course, then solving for that variable. Alrighty, moving on to the getting started. Now, the purpose of this getting started activity is to show you exactly how you would set up an equation using a double number line. So it reads, consider this double number line. The expressions 12 and 3x have the same location, so they have the same value. Now, what do you think that means? They have the same location, so they have the same value. So that means that those two expressions starts with an E, equal. That is correct. Also notice on this double number line, they started with 0 and 0x. Always start your double number lines with 0 and then use that 0 to then be your guide to where you're going to place your variable numbers and your single numbers. Alrighty, let's get into these questions. So question number 1 says, write an equation to show that 3x and 12 have the same value. Remember, if they have the same value, they are what? Equal. So I'm going to show you how you should represent that. And then number 2 says, extend each number line in both directions by identifying and labeling additional equivalent relationships. Explain the reasoning you use to place each relationship. I'm also going to model that so that for the next couple questions, you'll be able to do it on your own and discover on your own. So looking at number 1, we're first going to write our equation. I can see that 12 and 3x, again, have the same location. So I can write this as 12 is equal to 3x. And there's our equation. That simple. You can literally look at this line and pretend there's an imaginary equal sign. Now, some of you may even be able to solve this in your head, but we're not there yet. We're simply looking at how to set this up and how to write an equation from the double number line. So moving on to question number 2, it says extend each number line in both directions by identifying and labeling additional equivalent relationships. So both directions meaning this direction on the number line and this direction. And there are many ways that you can do this. There are several ways you can do this. I'm just going to give you one example. Here's my first example. Notice what I did. I multiplied both the top and the bottom, so both sides of the equation, by the same number. I multiplied them by 2. 3x times 2 gives us 6x, and 2 times 12 gives us 24, which means that 6x also is equal to 24, hence my equation to the right. Also, throughout this video, be sure that you're taking the notes that I have, and if at any point you need to pause and get the notes down, just let someone know and we can get that done. Do not get left behind. Now for my extension in the opposite direction. Notice in pink, I multiplied both sides of the equation by -1. And remember, those parentheses mean multiplication. 12 times a -1 gives us a -12. And notice what happened to those numbers. They reflected over our origin, over the 0. 3x times -1 then also gives you -3x. Hence the equation, -3x is equal to -12. Pause here so you can get these notes copied so that you can use this to reference when working on the other problems. Alrighty, now that you've got that copied, let's look at the problems that you'll be discovering and looking at on your own. So question number 3A, and that's a typo, it's supposed to say 3B, says the exact same thing. Consider the double number line. You're writing an equation that shows negative 14 this time and 2x have the same value. And then, again, you're going to extend the number line in both directions, right and the left. And be sure to explain your reasoning. You're also going to complete question number 4 for this equation here. And then you're going to look at question number 5 and do the same exact thing. At this time, go ahead and set a timer for about 4 to 5 minutes. You can work on your own or with a partner, but use this time now to work on questions 3 through 5, writing an equation, and then also extending the number line in both directions. Pause here. Now that you've had time to work, we're going to go over the answers that I got. Now, for part A, it should be the same. But for part B, you may have different answers, and that's okay. Just make sure and check that they make sense and that they're reasonable. If you're unsure, ask a neighbor or ask your nearest teacher. For 3A, the equation that you should have set up is negative 14 is equal to 2x. Or think about this. Could I also write this equation as 2x is equal to negative 14? If you said yes, you are absolutely correct. And for part B, for my first extension, I did the same thing that I did in the first problem. I multiplied both terms, both sides of the equations, by 2. 2 times 2x gives you 4x, and 2 times a negative 14 gives you an even more negative number, negative 28. So the equation that I wrote to represent that is 4x is equal to negative 28. If you multiplied by 3 or 4, or any other number, I'm pretty sure your answer is correct. Just check your multiplication. Or let me rephrase that. Your answer is correct if your multiplication is correct. For my second extension, again in purple, I multiplied by negative 1. Negative 1 times 2x gives you a negative 2x, and that negative number then causes both terms to reflect over the origin. Negative 14 times another negative number, negative 1, gives you a positive 14. So that equation is 14, positive 14, is equal to negative 2x. Go ahead and compare my notes to yours, and whatever you don't have written down, you can use this time to pause and copy them down now. Alrighty, let's keep it pushing. Number 4. For 4a, the equation you should have wrote was 17 is equal to x plus 4. So if you wrote that down, go ahead and put a big check. I was going to say a bug check. LOL, I make mistakes too. A big check next to your equation. Alrighty, for 4b, I want to see if you can guess and see what I did to extend this number line. So let's look at the green first. What do you think I did? Take a second to think about that. If you said multiplied by negative 1, you're absolutely correct. Yes, I multiplied again 17 times negative 1 to give me negative 17. It reflected across the origin. And then x plus 4, that whole group, that whole expression, I multiplied by negative 1, making it negative x plus 4 in parentheses to show that I'm multiplying negative 1 times the whole expression, the whole thing. And then in blue, can you guess what I did? I simply added 1 to each expression. So x plus 4, I added 1 more. It became x plus 5. And then 17, I added 1 more, and that became 18. So my equation 18 is equal to x plus 5 is also true to this equation here. Take a second to get this copied down. You can pause here. Alrighty, and lastly, number 5. For 5a, the equation that you should have wrote based off of this expression on the number line, or these expressions on the double number line, is 21 is equal to 3/4 x. And again, in green, I extended it to the left by reflecting it across the origin by multiplying by, you guessed it, -1. And then I didn't reflect. I extended the equation to the right in orange by multiplying both expressions times 2. 21 times 2, and let me actually write this out for us that need to see it, times 2 gives us 42. And then 3/4 x, well, think about it. If I've got 3/4 and I'm adding 3 more fourths, well, how many fourths do I now have? I have 6/4. If you wrote 6/8, double check that number, because when you simplify 6/8, it simply becomes 3/4 again. You just created an equivalent ratio. So 3/4 times 2 gives you 6/4. Alrighty, and this concludes the getting started. You now know how to set up and write an equation using a double number line. Couple key things here. Remember to always start with 0 and 0x, or 0m, 0t, whatever that variable is. I will see you in the next video.